In this video, we will be determining the greatest common factor using factor trees. We're going to determine the greatest common factor of 45 and 120 using factor trees. First factor the 45 as 5 times 9. We can further factor the 9 as 3 times 3. Now we have all prime factors, so 45 can be prime factored as 3 times 3 because there's 2 3's, times 5 because there's 1 5. Let's look at the 120. 120 can be written as 12 times 10 because it's ending in 0. We can further factor the 12 as 3 times 4. We can further factor the 10 as 2 times 5. Now we can further factor the 4 as 2 times 2, and we have all prime factors. So 120, written as a product of prime factors, we have 1, 2, 3 2's, so 2 times 2 times 2. We have 1 3, so times 3, and we have 1 5 times 5. We need to look at our prime factors, and we need to look in both prime factorizations. We need to look at the common factor. So there's a 3 in the prime factorization for 45 and a 3 in the list of prime factors for 120. There is a 5 and there's a 5 in the 120. So our greatest common factor will be the product of these two common prime factors, which is 3 times 5. So we get 15. Another way to write this is the GCF and then brackets of 45, comma 120 equals 15. This tells us that the greatest common factor of the two numbers 45 and 120 is 15. Let's determine the greatest common factor of three numbers, 40, 54, 72 using factor trees. For the 40, we can factor the 40 as 4 times 10. The 4 can be broken down to 2 times 2, both prime numbers. The 10 can be factored as 2 times 5. Those are all prime factors, so we're done. 54 can be factored as 9 times 6. The 9 can be factored as 3 times 3. The 6 can be factored as 2 times 3. All prime numbers. We're done prime factoring. 72. The 72 can be factored as 9 times 8. We can factor the 9 as 3 times 3, the 8 as 2 times 4, and we can further factor the 4 as 2 times 2. And now we're done prime factoring. So now we can summarize that 40 can be written as there are 1, 2, 3 2's, so 2 times 2 times 2, and there's 1 5, so times 5. 54 can be written as 2 because there's 1 2, and there's 3 3's, so that means times 3 and 1 more 3. The 72 can be factored as 1, 2, 3 2's. There's your 3 2's and 2 3's. So there's our prime factorizations. Now, in order to get the greatest common factor, we need to identify common factors in each list. So there's one common factor of 2. That is a number that exists in all three prime factorizations. There is no other one that is in all three. That makes the greatest common factor 2. We can also write it like this: the greatest common factor of 40, 54, and 72 equals 2. Please proceed to the next video in this lesson, and thank you for viewing.